All right, so before the break, we started on solving log equations, okay? And then which has log, right? So that's why you can apply the log law. And one thing very important is at the end, when you get the answer, you need to make sure it still makes the inside brackets positive, okay? That's how you check the answers. And if you check both answer then and both reject, then at the end you just say no solution. Okay, sometimes that could happen. Sometimes you keep both, sometimes you only keep one. Okay, then next one we're gonna look at an equation as well, but this time the equation it doesn't have any log. Okay, so if it doesn't have any log, then we can just log on to create the log. Okay, we've seen log on before when we were doing some proving, right? So this is called solving the log equation by log on. Okay, because it doesn't have log, so we put the log on. This kind of equation, we've seen it before, but before it was able to turn into same base, right? So for example, if you have 3 to the x minus 2 equal to 9, right? 3 and 9, they have a connection, right? Then you can make it into same base, right? 3 squared is 9, and then drop the base, and you get x equal to 4, right? This is something we dealt before. But this time, instead of 9, we have a 7. So that's why you cannot make it same base anymore. And that's where the log comes in, okay? So this one is using same base. Okay, using same base to solve. But this one, you cannot use same base. So we are going to log on, okay? Log on. So we put log on both sides. Okay, you can use any base, but here we just keep it simple, just a log base of 10. So that's why I don't need to write the 10. Also, because the calculator, you will need to have a calculator handy, okay, for this one. As you can see, the question says, please answer accurate to 2 decimal places, okay? So your answer will have decimals. So in the calculator, all the log button has base of 10, okay? So that's why it's more convenient if we use base 10. So you do log on, okay? Once you have the log on, then you have the log laws to apply. You have an exponent here, right? X minus 2, that's our exponent. So log of power tells us we can bring it down to the front. Right? We bring down the exponent to the front. Can anyone spot any mistakes we have here in this line? What mistake did I make? Yeah, Daniel?
I think you would need a bracket for like the log 3.
For log 3 like this?
Yeah.
Okay. Yeah, that's good. You could have you could have bracket around that or not. It doesn't matter because we know the 3 is in the log. It's one thing, okay? One term. So bracket or not, it doesn't matter. Not the main mistake. Anyone else?
You need brackets around the x minus 2.
That's right. Okay, the bracket should be around x minus 2. Okay, because log 3 is already together. They are bound together. But x minus 2, if you don't put bracket, then the minus 2 is not tied to the x. Okay, because x minus 2, the whole thing should be one exponent. Okay, so be careful about here. If you don't have brackets, that means the 2 is the only number that's multiplying the log 3, not x minus 2. okay? They need brackets here. So log 3 is just a number, okay? Some mystery number, which we don't know, okay? So we just leave it as log 3. Our goal is try to find x, right? So now this is algebra. Think of this question like this on the side, okay? I'll just write it on the side. If I have x minus 2, instead of 3, instead of log 3, I write 3. Instead of log 7, I write 7, right? Then the question looks much easier. So if you want to solve this, you would need to expand the brackets, right? So we're gonna do the same thing here. So log 3 is going to multiply in, okay? So give us x log 3 minus 2 log 3 equal to log 7. Does anyone have questions so far? How we get here? Okay, we're gonna do same thing on this side. So we have 3x minus 6 equal to 7. Okay. Okay, so what do we do next? Our goal is to isolate x. Evan, what do you think we should do in the next line?
Move the 2 log 3 over.
That's right, okay. So we would, on the left side would just be x log 3. And what will be on the right side then, Evan?
Log 7 plus 2 log 3.
Okay, it's the same way that you would do normally with the algebra, right? So on the right side, for this one will be like 3x equal to 7 plus 6, right? Except if it's number, we could add them up, right? 3x equal to 13. Okay, so what should we do next? Wayden?
Do we combine everything?
Combine which part?
The right side.
Which side?
Right side?
Okay. For the right side, because it has logs, so we cannot really add them up or multiply them. Well, you could use the log law, okay, but it's not necessary. We could just leave it like that. Other than that, what else can we do to isolate x?
Could you subtract log 3?
What's between the x and log 3?
Oh, divide by log 3.
That's right, okay? They are multiplying, so you do the opposite, okay? So you divide both sides by log 3. Okay, so this will be the expression. If they say they want an expression, you leave it like that. But if they want decimals, okay, so this is the point that you need to plug it into the calculator, okay? So let's get the decimal answer. We'll round it to 2 decimal places, right? So please take out your calculator, find the log button, okay, and then type it in. When you type it in, make sure the top is all together, right, in a bracket before you divide by log 3. All right, please raise your hand after you have found the answer for this one. Should be somewhere about 3 point something. Please raise your hand if you found the answer for this one. Okay, Angela, do you have any trouble using the calculator? Okay, what's your answer, Angela?
Uh, 3.77.
Yep, very good. 3.77. Okay, so for this one, because the x is in the exponent, so there's no restrictions, okay, for this one. So it doesn't have to be, you don't need to check the answer, okay? What you get will always work. You only need to worry about the checking if the x is inside the log, okay? The x you're looking for. So this one, you can just box it. Okay, next question, let's take a look. All right, so for question B, okay, let you guys think about this, right? Compare question A and B. It has an extra 7 at the front, right? For question A, it's just a base of 3. This one, not just base of, not just the base, right? Also has 7 at the front. I think that's the only difference, right? Other than different numbers. So what do you think we should do first? Any suggestion? Yeah, Daniel, what do you want to do?
Can we just do log on?
Okay, so we can log on both sides. Yeah, of course we can log on right away. So I just want to mention some of the common mistake that people make. Okay, is to, you see a 7 at the front and then you just multiply together, make it into 14x. 14 to the x equal 5. Make sure you cannot do that. Okay, so please write this down. I was hoping someone make a mistake like this. Okay, so this is wrong. The reason why it's not okay to do this is because of the order of operation, the bit mass, right? It has an exponent, so 2 to the x, they are stuck together. Okay, you cannot do multiplying first. Right, so let's do log on because there's nothing we can do, right? Nothing else. So just log on both sides. Okay, equal to log 5. On the left side, everything is a log in the log, okay? So if you like, you can put a big square bracket, okay? All right, now we got log on. What can we do next? Any log law we can apply? Eric, what do you think? Can we do anything on the left side?
Can we do like log 7 plus log 2x?
Yes, very good. Okay. So another common mistake that could happen is to bring the x down. Okay. This is wrong. All right. Because there's still a 7 attached to it. So you cannot bring it down yet. So using the adding rule. Okay. Now, once the log base 2 of x, not base of 2, okay, log 2 to the x is alone, then the x can bring down using the log power. Okay, anyone has questions so far? Okay, once the x is down, then it's easy to isolate. Okay, Susan, what do we do next?
minus log 7 on both sides.
Yep, so we get x log 2 equal to log 5 minus log 7. Okay, and then, so we are at a step, same step, kind of like this one, right? Similar stage, right? X log 2. On the left side, we're x log 3. Okay, so we just divide both sides by log 2. Okay, we'll type it into the calculator once again. Raise your hand if you have the answer. Please raise your hand if you found the answer in the calculator. Okay, Marcus, what's your answer?
I got negative 0.49.
Okay, very good. That's right. Okay, does anyone have trouble getting this answer? Let me know. Usually common mistake is when you type it in, right? You forgot to have a bracket around the numerator. You need to make sure you got everything on the top first before you divide by log 2. Okay, so for this question, did anyone do a little bit differently? Is there anyone that got the answer differently? We're gonna look at another way, okay? So the way that we just did was we just went straight to log on, right? Because we said we couldn't simplify it, right? The 7 cannot times the 2, right? But there's something else we could do, right? Let me copy the question here. And we'll see if it simplifies the steps a little bit. So instead of log on, I'm going to divide both sides by 7 first, okay? So it will look like this, 2 to the x will equal to 5 over 7. So what's the point of doing that? If you compare the look right now, it's kind of like the left side now, 3 to the something equal to 7, right? 3 to x minus 2 equals 7. And this one, right, 2 to the x equal to 5 over 7. Once you get here, okay, instead of log on, I'm going to, well, I could still do log on, okay, to keep it simple because we want to use calculator, okay, so we put the log on. X, I can bring it down now, right, because it doesn't have more than one thing. Okay, I just did the log on. And then you can see that x, you just need to divide by log 2, right? On the left side, you just need to divide by log 2, and then you got it. Kind of simplify the step a little bit, okay? If you look at the log 5/7, it matches this part, right? So you can see it's the same, right? 5/7, the dividing, I can split it into subtraction. So it doesn't matter which way you do, just make sure everything is okay, right? Okay to do, right? You cannot multiply the 7 and 2, but if you divide by 7, it's fine. All right, so the rest of the time, I want to cover the word problem. Remember last time we skipped the word problems? Okay, we only did the compound interest. Okay, we're gonna roll back the pages, a few pages back here. Okay, type 2. So please turn to page 92. Okay, raise your hand if you're on page 92. Okay, Chris, Eric, and Jocelyn, are you on the page? Jocelyn, are you on page 92? Jocelyn, yeah, okay. So type 1 was the compound interest, okay? I think almost everyone got it right in the homework, okay? So this is exponential because it grows, right? With the exponent. Exponent is the time, right? Now, type 2 is more of a general. So anything that gets bigger and bigger, or anything that gets less, right? Decay, growth, and decay, we have a formula for that as well. And the way it increases, it's not just using interest rate, okay? It could be other kinds of rate. Could be any percentage, right? Could also be decreasing. So let's look at our first example and then try to derive a formula for it. So here we have an endangered species of bear, okay? It started with a population of 10,000, okay? And then we are estimating the population is decreasing at 5% per year. So usually the rate they are always giving you in per year, okay? So let's look at the chart. Year T is 0, that means initial, right? So no decreasing has happened yet. So 0 times the decreasing happened, right? A of 0 means amount of bear, right? Number of bears at initial time. So that's 10,000. After 1 year, so it decreased once, right? At the end of 1 year, it's 5% less. So it'll be 10,000 minus the 5% of 10,000. Any questions so far? We're decreasing by 5% after 1 year. Now, if we take out, factor out the 10,000, it'll be 10,000, 1 minus 5%, so 0.05. So that's the amount after 1 year. So if we do the same thing, kind of like compound interest, okay? So amount after 2 years, you do the same thing as before. You take what you have left after 1 year, so which is A1, right? This is amount after 1 year minus the 5%. of A1. And then we factor out the A1, which will be 1 minus 5%, 1 minus 0.05. So you can see the 0.05 keeps happening, right? And because the A1 we set here is this thing. Okay, so we're replacing it. So that makes it 10,000 times 1 minus 0.05 squared. Because the two brackets are the same. Okay, can you raise your hand if you caught up to here? So if the question changes, right? If it says increasing 5%, the pairs are growing more and more, then instead of 1 minus, it will be 1 plus. So the 1 is like no change, right? The original. So if there's an increasing, you add it to the 1, right? If there's a decreasing, you subtract from the 1. Okay? So after t years, it'll be AT, right? A of t will be 10,000. That's our original. And then 1 minus 0.05 to the t. So this part, I just called it the rate. Okay? If it's growing, it'll be 1 plus some percentage. If it's decreasing by some percent, it'll be 1 minus the percent. Okay? And then this part is your original, right? 10,000. This part is the time you left it there to grow, time. Okay, so it could be 1 plus, could be 1 minus, but we just, in general, just called it the rate. Okay. So please copy this down, raise your hand when you're done. So the most important thing is to know how to set up, okay? Know what number to put into the formula. Okay, please raise your hand if you finish writing down. Okay, Evan, Justin, Wayland. Okay, so we are here. We just practice how to fill in the numbers. Okay, so let's look at question 8. So this one is about a house. Okay, question 8 was purchased for this amount of money, right? And every year is increasing by this much. So please write the function for it. Okay, a of t equals. Okay, so try it out. This time is increasing. So raise your hand after you got the function. Okay, Chris, what do you have?
355,000 brackets 1 plus 0.12 brackets to the t.
Okay, very good. Okay, so this one, because it's increasing, then you use 1 plus to figure out the rate. Okay, so this is rate. And this one is how much you purchase with, right? So this is the initial, right? Initial amount, A0, okay? So that's if they're telling you whether it's decreasing or increasing, you use 1 plus or 1 minus. Okay, please raise your hand if you're done. Okay, just question A. Question B, you just plug it into calculator, okay? You put the 10 years, right, into T and then type it into calculator. Okay, please raise your hand if you finish writing down the function. Okay, Eric, Evan, Wayland, do you need more time? Okay, so let's look at another kind of growing or decay, okay? This one is called the doubling. Sometimes it could be double, of course, right? It could be triple, right? Depending on the different kind of things you are growing. Sometimes it could be getting half, okay? So double is like 200%, right? Half will be like 50%, right? So they can make up any kind of rate depending on the question. And instead of every year, another thing that's different about this one is it says the bacterium is doubling every 7 days. So it has a special changing period. We call this the life period. Okay, please write this down. So it can change. They can say it doubles every 2 weeks. It become half every 2 days. Okay, it can change to anything. So instead of every year, this life period can change as well. Okay, Chris, you have a question?
No, that was an accident.
Oh, okay. All right, so let's take a look at how will the formula change for this one. So we started with a bacterium, that means 1, right? So 1 bacterium. So number of time doubling has happened so far is 0. You started with 1. And because it doubles every 7 days, so we are going by 7 days, okay? Instead of 1 day, 2 day, 3 day, okay? Because nothing happened in between, right? So after 7 days, it doubles once. So I put 1 there, okay? So that means after 7 days, you will see 2 bacteria, right? So 1 times 2. Another week has passed, so double happened again, right? 2 times now. So what you had before, right? Before was 1 times 2, you have to double again. So I write another times 2. So that means it become 1 times 2 squared. Okay, if I do another one, right? 21 days, that's 3 weeks, then it will be 1 times 2 to the cube. Make sense? So this 2 depends on the number of time it doubled, right? If it's square, that means double twice. If it once, it'll be doubling only once, okay? So if a t days, right? How many times does it happen? 14 days will be 2 times. 21 days will be 3 times, right? What about t days? What should go into this blink? Anybody? What should go inside that blink after t days?
Is it
T over
T?
7.
Yeah, Jenny?
Someone else had the right answer.
Oh, I didn't hear it. Philip, what did you say?
T over 7.
T over 7. Yeah, okay, very good. T over 7. So you need to figure out how many 7 there are, right? If they say the life period is 2 days, then you need to divide by 2, right? Depending on the question. So we get our 1 times 2 to the t over 7. This 7 is called the life period. Okay, this 2 is still called the rate. Except this time the rate is double, right? Double is 200%. So you don't use the 1 plus or 1 minus because they don't give you a percentage. Okay, they tell you it's double. This one is your initial. So there is our formula, okay, for this question. Okay, can you raise your hand after you copy this down? Okay, Kevin, Jenny, and Joseph, do you need more time to copy it? Okay, so let's take a look at a question, okay, that has to do with this one. We already have the function, right? A of t is 1 times 2 to the t over 7. So the question is asking how long, right? So that's talking about time, right? How long it takes for a single bacterium to grow to this much, right? This many bacteria. So this part, the A of t, maybe I should put here, and this will be your final amount, right? After t years, or no, actually for this one, after t days. So your final amount, you want it to be 8 to the 30, right? So you put it on the left side, 8 to the 30 equals to 1 times 2 to the t over 7. The 1, you could just make it invisible, right? Anything times 1, it doesn't make any difference, right? So we just write it as 8 to the 30 equals to 2 to the t over 7. Okay, so this is called an exponential equation. Of course, you can do the log on that you just learned today, right? Log on both sides, so for the t, or because you see the 2 and the 8, they have a connection. You can make it same base. Okay, so I'll let you figure this out. Make it same base and solve for t. Okay, it will be similar to where? Which question do we do? Yeah, here. Okay, same base. Make it same base and then drop the base. Solve for the exponents. All right, so I'll let you guys figure out the time for that one. Okay, raise your hand when you got an answer. So T equals the unit will be days, okay? So these ones, the T and the 7, they should have the same units. So if they give you in weeks, every 7 weeks, then the answer that you get will be in weeks as well. So you don't need to change everything into days, right? If they say it doubles every 7 weeks, you just do everything in weeks. Or years, then you keep it in years. Okay, Susan, how many days did you get?
630.
630 days.
Mhm.
Okay. Jenny, how about you?
I got 231 days.
231 days. Okay. Anyone else? Waylon?
I got 630 days.
630 days. Okay, so let's go over the steps, okay? Because 2 and 8, they have a connection. The 8, I can write it as 2 to the 3. Right? Make it same base. Oops, T over 7. And then 3, on the left side, 3 and 30, they can multiply together, right? 2 to the 90. Now they both have same base. We drop the base. So 90 equal to T over 7. And then multiply both sides by 7. That should give you the 630. Okay, Jenny, do you follow?
Yep, I added the exponents instead of multiplying them, so that's where I did it wrong.
I see, I see. Yeah, okay, so exponent next to each other will be multiplication. Okay, can you guys raise your hand if you got everything here? Okay, you have some word problems similar to this, okay? So you need to know what number to plug it in. Okay, please raise your hand after you copy the steps down. Okay, Evan and Justin, do you need more time? Okay, so let's look at the formula now. Okay, we can now fill that in. So the formula for anything that grow or decay, right, will be A of t. That's the final amount equals to A of 0, your initial, times it by the rate. Okay, rate could be 2, could be 3, right? Some of it could be half. If they say it's getting by half to the okay. over P. So this part, the P is called the life period. Okay, this is the initial. This is the final amount. This is the rate. Well, just rate. Growth rate. Could be decay, could be growing. So let's just make a note on the top. The rate, if it's it could be 1 plus the percentage. Okay, or 1 minus the percentage, right? Okay, let me write it this way. Increase or decrease by percentage. It'll be 1 plus or minus a percent, okay, for the rate. If it's a double, then the rate will be 2. Okay, if it's a half, then the rate will be half. Okay, so this is for the rate. So it can be anything, right? Most common one you see will be like double or half. And then the period, right? 7 days, you can call that the double life or the half life, okay? So that's why I call it the life period. So if you look at the question before, this is called the double life. Then they will say it has a double life of 7 days, okay? So that's what it means. All right, take your time, copy this down. So I'll give you a couple questions related to this kind of question, right? The life problem, growth and decay. Okay, raise your hand if you finish all the copying. And then we'll call it a day, okay? So we still have 4 more classes. I think next week we'll be starting on book 2. All right, so get your book 2 ready, take it out. All right, that's all. I'll see you next week. And if you have questions, please stay after class. And yeah, okay. Have a good weekend.
Thank you, Jason.
Thank
Thank
you.
you.
Bye. Bye.
Thank you.
Okay, and Evan, you have your homework ready or?
Just one more question.
Okay.